In this video, I'm going to show you how you can merge your transactional data sources, such as a relational database, into your transactional data lake in AWS S3. For this, we are going to use AWS DMS to put the CDC information from our source database into our data lake. And then we are going to use AWS Glue to apply the merge transformation into another bucket inside AWS S3, which will be an Apache Iceberg table. I found that there are not that many resources on this topic. That's why I decided to make this video and to provide you an end-to-end guide how the solution could be implemented. The whole solution will be completely serverless and automated end-to-end. So without further ado, let's get started. Before we get started with the actual implementation, I wanted to cover some basics about what CDC or Change Data Capture actually is and when it makes sense to use it. So what is Change Data Capture? Our end goal is basically to move data from our source database to our target system, which is typically an analytical data store such as AWS S3. For this, a very straightforward approach would be to just dump the whole source database once every week or once every month into the target system. And then this way we would have like some kind of snapshots in our target database, which shows the status of the database at a specific point in time. So what we could do instead is that we could use the transaction logs that are written by most database engines, which contain all of the information about inserts, updates, and deletes that were performed on the database. Then we would need to have like some kind of system in between. Here it is called a transaction log miner that is going to collect all of this transaction log information and then is going to send this information into our target system, in our case into AWS S3. So what we would end up then in our target system is that we would have a bunch of different records, as you can see on the right, which contain usually an ID of the row that the transformation was applied to. Then we would have all of the different attributes of that specific row. And then very importantly, we would also have some kind of information, whether this was a delete, an update, or an insert, as you can also see on this picture here. And yeah, this basically is Change Data Capture in a nutshell. So we collect those transaction log information. We have some system in between to move this information into our target system. And then we would have all of those different records, also with the indication of whether it was an update, an insert, or a delete. And then the next step would be usually to apply those operations, to apply those updates, so those deletes, those inserts into our target table in our data lake, basically. So you may be wondering, when do we need CDC? When does it maybe not make sense to use CDC? For this, I have put down 5 situations or 5 aspects here on the slides. I'm sure there are many more, but yeah, generally saying, if you have a lot of data in your source database and you want to have updates on your data lakehouse or transactional data lake quickly and don't want to always copy the whole snapshots of the whole data, you can use CDC. Also, if you have like complex downstream processing in your data lake and you don't always want to apply the whole processing logic on your whole database, then it also makes sense to use CDC and only apply the logic on the new arriving data, basically. It also makes a lot of sense to use CDC if you have some kind of transactional data lake or lakehouse in place and you're using an open table format such as Apache Iceberg or Apache Hudi or Delta Lake, and then it becomes relatively easy to apply your CDC logic, as those open table formats support those inserts and updates and delete operations. And last but not least, we have data regulation. So if you need to make sure that if data is deleted in your source database, it also needs to be deleted in your target systems, then it becomes relatively easy to use CDC to just apply this delete statement also on the data lake using our transformation logic and our open table format. All right, so let's look into our solution architecture. Going from the left to the right, we have Amazon RDS as our root database, where we store our relational data. In this case, we're going to use some Airbnb data, which I will show you later in the demo. And then we have AWS DMS that is responsible for moving the change data capture information from our source database into our data lake in AWS S3. And as you can see here, we are using the bronze, silver, gold architecture, which is very common for data lakehouse architectures, where in bronze we have stored our raw data. Basically, in this case, this will be our change data capture feed. In silver, we will have our cleaned data set, where we have already applied our merge operation from the change data capture feed. And also in our use case, we will apply some kind of cleaning of the data so that we have a clean state in our silver bucket. And then typically we also have a gold bucket where we have all the aggregated and joint data stored inside that is typically used then by BI applications, by Amazon QuickSight or by Power BI, for example. And as you can see here, we are going to use Apache Iceberg here as our open table format on top of our data in the silver and the gold bucket. And the reason for that is that this makes it relatively easy to apply this merge transformation of the change data capture feed into our silver bucket. And yeah, all of our data will be cataloged in the Glue Data Catalog. And to automate the process basically end to end, always when a new change data capture feed is uploaded into our browse bucket, an AWS Lambda function will be triggered that then calls basically our AWS Glue job, which then again performs the merge operation and the cleaning operations to write into our silver Apache Iceberg table. I hope this makes all sense. If not, I'm going to show you the demo next, and this might clarify all of the open questions. All right, so let's look into how this could look like in practice. So I will guide you through all of the services used in this solution, starting with RDS, as this is where our data is stored. So if we click in to the databases here, we can see that we have one database here created. This is an Aurora Postgres SQL database, which is a serverless V2 database. So in our case, we are using Airbnb data here. That's why it's called Airbnb serverless. I will show you how the data looks like in a second. But first of all, I wanted to mention one more thing. As in most database engines, there are some kind of configurations that needs to be applied first before you can actually use change data capture for these databases. So in this case, as we're using Postgres, what I did is that I have created a parameter group here. So as you can see here, under custom parameter groups, I have created this CDC cluster parameter group. And what I have changed here is that I've set one parameter, which is called RDS.logical replication. And I've set this one to, it was previously set to 0. I've set this one to 1. And with this being set, we can now use the transaction log basically to then load the change data capture feed from here to our target system. So if you're using another database engine, you need to make some kind of research if you need to enable some parameters on this database so that you can actually use the transaction log there. All right. And now before we move on, let's have a quick look into the data itself. All right. So we can use this query editor here, as it can be used for serverless databases. And we have this database stored here called demo hosts, or hosts demo. I think it's called the other way around, hosts demo, and just run a select star out of it. So we can see here that we have a couple of records here, only 10 records for demo purposes. And each record does have an ID and URL, which is basically the Airbnb URL for the host. Then we have a name, we have a date since when this host is using Airbnb. We have a location that is set on a profile of this host. We have a response time and a response rate stored here. And the next step, as you have seen in the architecture diagram, would be to use AWS DMS to migrate the CDC information of this database into our target system, which is AWS S3. So let's look next into AWS DMS. Here there are a couple of things that need to be set up. First of all, I have created 2 endpoints. I've created one endpoint for the database, so for the PostgreSQL database, which is the first entry here. And then I have also created a target for our data lake in AWS S3. The third one here is just a test. Okay, and then we have some kind of configurations made for those 2 endpoints. If we look, for example, into the S3 target endpoint and look into what we have configured here, as you can see, it's the target engine S3. I've specified the IAM role to access this data, things like that, the bucket name, the folder path, basically. And then here we have some endpoint settings, and here are some important ones, which I also wanted to mention. For example, we have added a timestamp here called last updated timestamp. And what this will do is that it will add an additional column to our data, which will be stored then in AWS S3, which contains at which time this operation of an insert or an update or delete has happened. And this information is very much needed for our merge statement that we will apply later on. So it's very important to add this column here. Maybe your source target table already has this kind of information, but in my case it did not. So I've added this column here. And it will basically look into the transaction log and see when this transaction actually happened. I also set this parameter here to true, which will ensure that for the initial load of the data, which is called the full load, also the operations column, which will indicate that in the first one, of course, it will all be an insert, and this will be then also covered in the target system. All right, and then some other settings here on CSV, how my data will be actually stored there. But those 2 are the most important ones, so include operations for the full load and setting the timestamp column here as well. And what we can then do here in DMS is that we can create a so-called migration task. And here you can see I've stopped it because I've run it already previously to test it. And this is where I configure the actual migration of the data, of the change data capture feed. So I have created a migration task here to use the source database and the S3 as a target. And I have configured it to do a full load and then to do ongoing replication. And this means that once I start this task here, it will load the complete database that is currently there in RDS. So it will be all insert operations then basically, and then it will also look for ongoing tasks there. So if I will then insert something or delete something or update something, this will be also covered by this task and sent to our S3 destination. So let's do that. Let's start this task here. And now the task is basically starting, and we will wait until this is running, and then we will see what we can see already in our destination S3 bucket. All right, now as you can see, the load completed and replication is ongoing. And what this means that the initial data that was stored in my RDS database is now migrated into S3. So let's have a look. Let's look into our destination. As you can see here, I've created 3 different buckets. Basically, the medallion architecture that I was talking about earlier with having the raw data, the cleaned data, and the aggregate data. And our DMS task is configured to send the data into our browse layer here. So we click inside. I have further structured it into DMS, Airbnb database, and then it comes the schema of the database and then the actual table that I've selected in the task to be used to send the CDC data. And as you can see here, we have one file, and this contains basically all of the inserts. So the 10 records that we've seen earlier are all basically written to this file. We can now use AWS Athena to look into this file. We could also just download the file and look into the CSV file, but let's use Athena for that. So I have created previously two tables. I've created a browse table and a silver table, basically for the raw data that was sent by the DMS task. And if we look into the columns here, we see these columns here that we have also seen in RDS when we looked into our data. So we have our ID, the URL, the name, the since, location, response time, response rate. And then we have two additional columns here. The first one being the operation that was performed. So in our initial load, this will all be an insert. But later, if we apply updates and deletes, this will be stored in this column here. And then what I've also shown you in the DMS configurations, we have this new column here called last updated timestamp, where we will see when this actual operation was performed. Now let's just query this data and see what's inside here. And as you can see, it looks exactly the same as we have seen in RDS, but now we have like the operation, as I said, all inserts, and it is just the initial load, and also having this last updated timestamp here. All right. If you remember the architecture, if we quickly look into it once again, you see here that we have now covered the first part. So we have seen how RDS is configured, how DMS is configured, and how the data is stored in our browse layer here. And as we have performed this migration in DMS, a Lambda function was triggered to execute an AWS glue job to then insert those or to merge those insert operations, those CDC information into our silver data lake S3 bucket. And this is what we're going to look into next. All right, so let's have a quick look into the Lambda function that was executed when the data was uploaded here in our browse table. I called it here trigger glue CDC job, and this is a very, very straightforward Lambda function. All it does is it basically calls an AWS glue job, which is called browse to silver, and just starts basically the execution of this job. And what this job does, we will look into next here if we go into AWS glue and go to the ETL jobs here. And here we can see this exact same job that was called by the Lambda function. And if we click inside it, we can see what is actually happening here. As I've mentioned earlier, this is a Spark application that is executed, and I will guide you through the steps that are executed here. All right, so first of all, we are reading the input data here. So we are reading the host's browse table that we have just seen in Athena. And after that, we need to perform some kind of logic to make the merge operation working correctly. First of all, we have this deduplication part here, which is very, very key to make sure that the whole merge transformation works properly. This is crucial to make sure that we apply the change data capture information, so that inserts, the updates, and the deletes in the correct order. And we do this by using a window function and a row number function here. And what we do here is that we look into all of the different rows in our source database, and then we partition it by the ID and we order it by the last updated timestamp. This is why I mentioned earlier that it's very important that we have this last updated timestamp, because by this timestamp, we will define in which order the operations were basically performed. What we do here is that if we have like a couple of different operations on the same ID, let's say we have like on the ID 1, we have an update and afterwards a delete, we only want to apply the delete. So we don't want to apply the update first because it's not necessary to do that when it will be deleted afterwards anyway. So what we do here is that we take only the last operation for all of the different IDs. And this way we will make sure that no unnecessary operations will be performed and that everything is basically executed in the right order. Next, we will have a cleaning step. This is also very often part of a script that is transforming from bronze to silver. So we are like casting some of the values, we are renaming some of the values, we are splitting the location column, for example, here into location city and location country. Previously it was both in this one column here. And afterwards we are creating a view here so that we can use this deduplicated data frame in our SQL statement that we will perform at the end here. So this merge operation here is the most important part, as this will perform a merge into in our host silver table. We will look into how this host silver table is defined in a second. As I've mentioned earlier, this is an Apache Iceberg table, and this is also the reason why this merge into operation here works. We use our deduplicated view that we have just created earlier. We look into the target ID, and then we basically perform the deletes, the updates, and the inserts. So whenever we have a match of the target ID and the source ID, we will look how the operation is. So is it a delete? Then we are going to delete this record. Is it an update? Then we are going to update all of the different columns here. And if it's not matched at all, then we are going to insert this record here. And this way we ensure that all of the different change data capture operations are correctly applied to our target silver table, which is again an Apache Iceberg table. All right, so if this was too fast for you, I will publish a blog in the next couple of days as well, where I will guide you through all of the different steps here as well, also provide the source code for it. Also for the glue job, it's very important to do some job configurations here. For example, we need to set the correct IAM role, but more importantly, we also need to set here a couple of job parameters to make sure that this whole script works as it is working with Apache Iceberg, and then we need to set some parameters here as well. All right, so now let's look into our target table that was created by the script. So if we go back to Athena, and first of all, look into how the table was configured. We see that it has basically the same columns as our browse table, but we don't have the operation column here inside anymore. And we have some different data types here. We use the date here instead of a string, for example. We use a timestamp here for last updated, where it was a string in the browse table. And we have location city and location country, whereas in browse, if we look into it once again, we had only the location column, where we had the city as well as the country stored both inside here. So as part of this cleaning operations, we have those two columns here now. And then very importantly, we specify that this is an Apache Iceberg table using the Parquet format. and also specifying the location where this data will be stored. And if we query the data now in the next step, all right, over here, we will see, all right, we have data here, which means that our glue job was executed successfully. We can also have a look into the last runs here, click into job run monitoring, last hour, and then we see that this one was just executed. Again, it was triggered by the Lambda function because data was uploaded to our raw S3 bucket, and then this merge operation was applied here. All right, so what we can do next is if we do some inserts, updates, deletes on the database now, if this will also update our browse table here. So we go back to RDS and we will perform some inserts, updates, and deletes here next. All right, so now I've defined 3 different operations on the database. So I will insert a new record over here. I will update a record where the name is Ron to set the name to Ron updated. So it is this row over here. And I will also delete one row where the name is Lawrence. This will delete this row over here. So let's execute those 3 statements. This one was successful, 1 row updated. Let's update this one, also successful, and then let's delete this one. And what will happen in the background now is as our DMS task is still running, it will recognize that we did some operations in our source database, and it will now send this kind of information into our browse layer in our S3 bucket. So if we go into S3 over here and we update this, it will take like a minute or something, whatever is configured in our DMS task. And then we will see that we have a new file here containing the updated information. All right, it was sent over here. So we can see we have a new file. And if we go into Athena and again query our browse table over here, we will see that we have 3 new rows over there. We have an insert, we have an update, and we have a delete. And this is exactly what I have performed on the source database over here. And you also see the timestamp over here, which specifies when this kind of information was basically applied, which is very important for our deduplication logic. All right, so now let's see if we go back to Glue and look into the total runs here. We should see in a couple of seconds that another glue job will be triggered as our Lambda function again got executed by the upload of the data. And this should again trigger a job here. All right. As you can see here, I just needed to refresh it properly. We can see that another job was executed. And if we go now back to our Athena query editor and we look into our silver table and select star from it, we see that now we have this new record inserted that I have just inserted in the source database with Thomas here. We can see that the name, which was previously Ron, is now Ron updated. And we can see that the column, that the row with the name Lawrence that we have deleted here is also deleted in our target database. So all of the CDC transformations that were applied on the source database are now correctly performed on our host server database. Okay, one last thing that I've wanted to show you here is that as we are using Apache Iceberg, we can now make use of the time travel feature of Apache Iceberg and look into the state of the database as it was a couple of minutes before. So we could specify here this query to see the state of this database 3 minutes ago. And as we can see here, we have still a Lawrence there. We can see that the row with the name Ron is not updated yet. We don't have this Thomas row here inside. So this is really the state of the data before we did all of this update operations there. We could also specify a specific version number over here, but we can also use this here to look a couple of minutes or even a couple of hours or days back in time. All right, so this is all I wanted to cover here in this end-to-end example. Again, if we look into the architecture diagram one last time, we see that we started with the RDS database. We used DMS to migrate the change data capture feed into our browse layer here in AWS S3. This triggered the Lambda function to trigger the AWS glue job to perform the deduplication logic, to do the cleaning on the browse data, and then to perform the merge operation into our silver bucket, which is an Apache Iceberg table. And then I've also shown you how to use the time travel feature in Athena using Apache Iceberg to look back in time before operations were performed. And all of this is basically automated here end to end. I hope you liked the video. As I've mentioned, I will publish a blog post with a couple of more details in the upcoming days. If you liked the video, leave a like and subscribe to this channel. I'm planning to upload more videos on data and AI topics in the future, so leave a comment if there is anything specific that you want to see, and have a good day. Bye bye.